Hello people, what up? My name is Rafael. On this video I want to talk about transformers. Transformers are used to change the voltage level of an electric signal. When we generate electricity, we need to increase the voltage level to transmit the electric energy from where it's generated to where it will be consumed. If we didn't do this, a great part of this energy would be lost through the cables. Therefore, we transmit electric energy in high voltage. Nevertheless, high voltage is too dangerous for consumption. Thus, when it reaches the city, it needs to be decreased to a level that best fits the consumer needs. The steady magnetic field. The source of a magnetic field may be a magnet, a changing electrical field, or a current flowing through a wire. The magnetic field in a transformer is created by a changing current that flows through each of its two windings. Therefore, we shall consider more carefully the field created by a changing current. However, we will first consider the magnetic field created by a direct current. A direct current is the one which doesn't change with time. It's constant. Ampere's law. Ampere's law says that the line integral of the magnetic field intensity about any closed path equals the direct current enclosed by that path. It's a way of measuring the intensity of the current and of the magnetic field. What we should know firstly is that a direct current produces a steady magnetic field about the wire. However, and what will interest us the most, is that a varying current will produce a varying magnetic field around the wire. It's highly important for transformers, for if we apply direct current on the primary of a transformer, it will produce a steady magnetic field through its core, what won't produce a voltage at the secondary. To produce a voltage on the secondary, we need a varying magnetic field. Faraday's law. In 1820, a Danish scientist named Ørsted demonstrated that a current affects a compass needle. Subsequently, Faraday professed his belief that if a current could produce magnetism, thus magnetism should produce a current. We now say that a time-varying magnetic field produces a voltage. Concerning transformers, we say that when we apply a time-changing current through the primary winding, it will produce a magnetic field which will be transferred through the core to the secondary winding. On the secondary, this changing field will produce a voltage, which in turn produces a current, which has a direction of creation of a magnetic field, which will attempt to fight the field that created it. The law of induction is also attributed to Lenz. The approach to better understand it is to say that a time-varying current in the primary winding produces a time-varying magnetic field which creates a varying magnetic flux in the core of the transformer. And this varying flux is what produces the voltage on the secondary. The minus sign in the expression indicates that the induced voltage on the secondary produces a current which has such a direction which will produce another flux which fights the main flux, the one that created it.